What if every twinge, ache, or blip on a medical test weren't just a signal of decline, but an invitation to engage with our own well-being through mindfulness? This isn't about wishful thinking. It's a radical reimagining of how our mental states can directly influence our physical health. That, in a nutshell, is a view of the award-winning social psychologist Ellen Langer. In this Blink to the Mindful Body, we'll explore how mindfulness isn't just a practice, but a powerful tool that can reshape our understanding of health itself. Langer's work challenges the pessimistic assumption that our health only moves in one direction, toward deterioration. Drawing on decades of studies, she provides astonishing evidence that our thoughts, beliefs, and perceptions significantly impact our health. Imagine hotel staff losing weight simply because they began to see their work as exercise, or patients healing quicker in rooms where clocks ran faster. These scenarios aren't from a science fiction novel. They're real outcomes from Langer's research, demonstrating the profound connection between mind and body. The mind and body aren't separate entities. The idea that mind and body are separate entities is deeply rooted in Western thinking. This idea, however, may not only be mistaken, plenty of research suggests it's downright harmful. Western medicine, influenced by philosophers like Plato and Descartes, long treated the mind and body as distinct. In this view, illness was traced to pathogens attacking the body. This perspective was bolstered by groundbreaking discoveries in bacteriology by scientists such as Robert Koch and Louis Pasteur, who identified specific bacteria responsible for diseases and developed vaccinations. These achievements, while monumental, inadvertently reinforced a model of disease focused on physical causation, sidelining the role of the mind. Eventually, a more nuanced idea of illness entered Western medicine, the biosocial model of illness. As the name suggests, it acknowledges biological, psychological, and social factors in health outcomes. But this model keeps the mind-body split intact. Researchers still tend to ask themselves how to get from a fuzzy thing called thought to the material thing we call a body. The underlying assumption that these two things are separate remains. But new evidence paints a different picture of this interaction. An analogy can help us here. Think of your arm. You can see it as an assemblage of different parts: the wrist, the elbow, the forearm, and so on. But when you move one part, you affect every other part too. Moving your wrist affects the position of your elbow and the tension in your shoulder muscles. In other words, you can't separate the parts. The wrist is simply part of the arm. Similarly, it appears that every thought that affects our minds also affects our bodies. For example, we now know that tears of joy are biochemically distinct from the tears we shed when we're chopping onions. Then there's the research of the pioneering scientist Asya Rolls. Her work indicates that immune responses begin in our brains. Upon inducing abdominal inflammation in mice, Rolls observed that specific neurons in their brains became active. Other researchers replicated this inflammation by directly activating these neurons, illustrating the capacity of certain mental processes to trigger actual physiological reactions. Rolls' studies also show that optimistic expectations can enhance immunity against bacteria and tumors. For instance, stimulation of the brain's pleasure regions led to a deceleration in tumor development. The upshot of this kind of research is startling. Thinking may have extraordinary healing powers. Positive thinking can improve our physical health. That's a fascinating hypothesis, right? So, how can we test it? Well, let's start with one of the author's own studies. She called it the counterclockwise study. The aim was to see whether immersing elderly men in an environment reminiscent of their youth could lead to measurable health improvements. The participants were divided into two groups. The first experienced a retreat designed to replicate life 2 decades earlier including watching old TV programs and reading media from that period. They were encouraged to only speak in the present tense, as though everything they discussed was happening now. The second group lived in the same retreat, but used the past tense to talk about their experiences. Remarkably, both groups showed improvements in various health markers, but the group living counterclockwise demonstrated significant enhancements in vision, flexibility, dexterity, and even cognitive function, challenging the notion that such physical attributes invariably decline with age. A similar experiment carried out in Italy 10 years later replicated these findings. Langer pursued this line of inquiry in follow-up studies. One looked at age-related cues around clothing. Advertisements often signal whom fashions are designed for, reinforcing ideas of what is deemed age-appropriate. Miniskirts, for example, are rarely offered in stores targeting middle-aged women. These discriminatory practices aren't just annoying, though. They also appear to impact our health. This becomes clear when you look at uniforms, a form of clothing that generally eliminates hints of age. Unlike people wearing age-appropriate clothing, individuals wearing uniforms at work don't receive constant, subtle reminders of their age. Langer's study found that the second group tended to have longer lifespans once you factored in variables like status and salary. Although we can't conclusively prove that the absence of age-related signals are entirely responsible for this phenomenon, it's plausible to suggest a connection. A second follow-up study looked at hotel housekeepers. Despite the physically demanding nature of their jobs, these maids didn't consider their work to be a form of exercise, viewing exercise as something done before or after work. Interested in whether perceiving their work differently could affect their physical health, Langer divided the participants into two groups. The control group received only basic health information, while the experimental group was informed that their daily tasks were equivalent to gym exercises. Throughout the month-long study, there were no changes in the intensity or duration of the maid's work, nor in their dietary habits. The sole variable was the perception of their work as exercise. The result? A shift in mindset led to notable improvements in the health of the experimental group, including weight loss, a lower body mass index, and reduced blood pressure. Perception has real-world health implications. The psychologists Alia Crum and Octavia Zart took this line of research one step further. The massive scale of their study makes it an important contribution to our understanding of the interconnectedness of the mind and body. In their study, Crum and Zart surveyed over 60,000 individuals aged 21 and older, taking into account various health and demographic factors. The survey queried participants on their perceived level of physical activity compared to their peers. And the findings revealed a significant link between individuals' perception of their physical activity and their mortality rates. Those who considered themselves less active than others were at a higher risk of dying during the study period, irrespective of their actual physical activity levels. This phenomenon isn't restricted to physical activity. Research by Abiola Keller, the director of clinical research at the Medical College of Wisconsin, showed that it's the perception of stress, not the stress itself, that impacts our health. Individuals who believe stress is detrimental and report high stress levels have a shorter lifespan compared to those who don't view stress as harmful, regardless of their actual stress levels. The influence of perception extends to other health aspects, such as sleep. Researchers from Harvard Medical School explored this by manipulating a bedside clock to display incorrect sleep times. Participants who thought they had slept for 8 hours, despite only sleeping for 5, performed better on cognitive tests than when they were aware of sleeping for only 5 hours. Conversely, those who slept for 8 hours but believed they had slept for 5 performed worse than when their perception matched an actual 8 hours of sleep. These outcomes were reflected in brain activity as shown in an electroencephalogram, or EEG, a test that measures electrical activity in the brain. Perceptions of sleep duration, it turns out, have a much greater impact on alertness levels than the actual amount of sleep. A team of researchers at Stanford found a similar pattern applied to perceptions of genes. Participants in their study were asked to perform an endurance test on a treadmill. Afterward, they were randomly assigned to two groups. The first was told that tests had shown they possessed a fatigue-prone gene. The second wasn't told anything. This information was sometimes accurate and sometimes misleading, meaning some participants were informed correctly about their genetic predisposition, whereas others were misinformed. A week later, all participants undertook the treadmill test again. The study's results highlighted the power of belief over genetic predisposition. Individuals who were led to believe they had the fatigue-associated gene showed diminished endurance, reduced lung function, and a less efficient metabolic exchange rate, indicating a decreased ability to expel carbon dioxide from their bodies, regardless of their actual genetic makeup. In other words, these individuals' beliefs about their abilities had led to real and negative physical outcomes. If we believe a treatment will work, it often does. All the evidence we've looked at so far points toward mind-body unity. Rather than being separate, our physical health is radically impacted by what's happening in our heads. An interesting way to further probe this idea is to look at research on placebos. Placebos are basically harmless treatments like sugar pills or saline injections. When they're used in research, one group gets the real medication while a second group is given the placebo. The purpose is to establish whether the medication outperforms a fake treatment. Patients often experience healing when they believe in the efficacy of a placebo, regardless of its form. For example, as one well-known study was able to show, patients stopped vomiting after taking Ipecac, a vomit-inducing agent, when they were told it would alleviate their symptoms. Similarly, individuals with viral sore throats have been known to improve after taking antibiotics, which are ineffective against viruses. Other studies have shown that the stimulating effects of caffeine only manifest when people are aware that they've consumed caffeine. The placebo effect appears to be stronger with more invasive procedures. For instance, sham surgeries have shown greater effectiveness than less invasive treatments like injections or pills. In 1959, Leonard Cobb, a cardiologist, presented a study on internal mammary artery ligation, a surgery intended to relieve chest pain. His research showed that patients who'd undergone a fake surgery reported the same level of pain relief as those who'd had the actual procedure. These findings have been replicated in all manner of contexts. For example, if you paint people's warts with bright colors and tell them they'll fall off as a result, they usually do. Tell someone with asthma that the inhaler you've given them will open up their airways and they'll experience significant relief, even if the inhaler contains no active drug. The list goes on. Sham ultrasound procedures can relieve the pain of people who've had their wisdom teeth removed and reduce intestinal inflammation in people suffering from colitis. Finally, there's the work of behavioral economist Dan Ariely, who's shown that the effectiveness of placebos is enhanced by their cost. Simply put, when we pay more for a medication, we're more likely to believe it will work. In many cases, that's a self-fulfilling prophecy. Now, the point here isn't that we should raise the price of medicine. Rather, it's more evidence that the potential for recovery lies, at least in part, within our own perceptions. The illusion of control can be beneficial. Our exploration of the placebo effect highlights a key variable in how our psychology affects the health of our bodies: control. Let's wrap things up by taking a closer look at this variable. Say you're in an elevator. You've already pressed the button for your desired floor, yet the doors remain open. As time ticks by, your impatience grows. You repeatedly press the button to close the doors, and eventually they do shut. Like many others, you might think your actions were effective, though they likely had no impact. Following the 1990 Americans with Disabilities Act, elevators in the US are required to remain open for a minimum of 3 seconds to accommodate those with disabilities, leading to the deactivation of many closed-door buttons. These non-functional buttons might not close doors, but they do something important. They give passengers a sense of control, easing the discomfort of a seemingly non-responsive elevator. This sense of agency, even if illusory, is significant. It suggests that the perception of control, rather than a mere delusion, can provide genuine benefits by aligning with our responses to situational demands. This perception influences behavior in a way that appears logical from the individual standpoint. Consider, by contrast, a world where the concept of control is understood as entirely realistic with no illusions. In such a world, choosing lottery numbers or pressing non-working elevator buttons would be deemed irrational. While this perspective might seem logical, it also introduces complications, particularly in managing stress and impatience without the small actions that offer a sense of control. Viewing the illusion of control purely as a fallacy overlooks the complexity of how control is manifested and understood. Dismissing the potential for control might prevent us from recognizing when we genuinely can influence outcomes. For instance, in the UK, elevator closed-door buttons are functional, a fact that might be overlooked by those accustomed to the American context, where such buttons are often inoperative. Hence, embracing the possibility of exerting control, even if it occasionally leads us to make less optimal choices, is advantageous because it acknowledges our capacity to impact our surroundings and manage our reactions to them. As we've seen, in the context of our health, when we believe in the impactfulness of a certain behavior, even if it's swallowing a sugar pill, that behavior really can lead to meaningful and desired outcomes. In this Blink to the Mindful Body by Ellen Langer, you've learned that the traditional view of health was long based on the assumption that mind and body are separate. But new evidence paints a different picture. Mind and body are unified, and what happens in our minds affects what happens in our bodies. In other words, perception significantly affects our physical well-being. As seen in studies on placebo effects and the perception of exercise, stress, and control, we can influence our health by changing our thoughts.